Hey everyone, in this video, I just want to give you some tips and hints for working through the examples and exercises in section 6.3. So number one is dealing with a one-dimensional rod again. So this is going to be very similar to example 1, part B. So please take a look at that video if you're having trouble getting started here. So for number 2, it's going to look very similar to example 2, part B. But just to get you started, let's go ahead and draw the picture of the object in this situation. So we're looking at a cloth banner that's 10 meters wide and 5 meters high. So we can go ahead and draw that banner out. So 10 meters wide, 5 meters high. So something like this. So we want to label 10 meters this way and 5 meters this way. So maybe it's a sign in front of a store or some flag of some sort. And now we're told that it rains overnight. And the next morning, the banner is heavier at the bottom. So there's more water here due to gravity's effect on the moisture in the banner. Specifically, we are given that the density of the banner at distance y meters from the top edge is given by rho of y equals 0.5 plus 0.1 y kilograms per meter squared. We need to find the entire mass of the banner. So then if we want to draw our slice to get us started, if we measure down here y amount, we can cut out a little slice. So notice too, we're also being helped here. We're told what the unit of the object is, area here. So we need our slice to have an area rather than a volume or a length. Like length, we saw in example 1 and problem 1, volume we'll see in problem 3. Okay, so here's our slice. So let's decorate and label our slice a little bit. So we have a change of y here. The slice length is going to be 10 meters. So then if we set up the slice and we can find the mass of the slice, well, again, that's going to be rho of y times area of slice. So for us, that will look like our rho is 0.5 plus 0.1 y, and our area is 10 times change of y. Okay, so then now it's your job to determine the mass of the entire banner. And you can use this work that we just did of the mass of a small slice to use an integral to compute the total mass of the banner. All right, so I'll let you take it away from there. And now part 3, I'll just give you a little insight, or maybe we'll just set it up together for how to work out this problem. So in part 3, we're told that a rectangular aquarium having a length of 3 meters, a width of 2 meters, and a height of 2 meters is filled to the top with a mixture of water and sediment. So let's go ahead and decorate that box. Okay, so we're told it has a length of 3, so it's long, it's 3 meters long. Then it has a width and a height of 2, so 3 meters that way. The width is 2 meters, and the height is 2 meters. Okay, at a depth of y meters, the liquid in the tank has a density of rho of y equals 1,000 e to the 0.05 y kilograms per meter cubed. So this is a volume. So that's going to signal to us too that the slices we take, we need to take 3-dimensional slices, or slices that have volume, not just area or length. Our goal is to find the mass of the entire liquid. So let's go ahead and look at what a slice of this water sediment would look like. Okay, so at y meters down, we can take a slice here. The slice is going to have a little thickness. We can call it delta y, or change in y. And then what will the volume of that slice be? Well, its thickness will be delta y. So the volume is going to be height times length times width. So the volume of a slice is going to be 2 by 3 by delta y. And that's going to be meters cubed. Each of these dimensions is measured in meters. Okay, so then together, let's compute or determine what the mass of a slice would look like. So mass of a slice would be about, assuming that it's going to be uniform density on that entire slice. And that's why we're doing this. We're getting a small enough slice so that it is uniform density throughout that piece. Okay, so it'll be our density, rho of y, times the volume of slice. So for us, that's going to be 1,000 e to the 0.05 y times the volume of a slice, 2 times 3 times delta y. And we can just check that units do work out. So our density is kilograms per meter cubed. 2 is meter, 3 is a meter, and delta y is a meter measurement. So we get 3 or meters cubed. So those meters cubed cancel out, and we're going to get kilograms rather in the end. All right, so there is what the density or mass rather of one slice is. So now we can use this to determine the mass of all of the substance in the tank. All right, so please feel free to rewatch parts of this video to help you get started on these examples and exercises. It's really great practice to go through these so that you're feeling really comfortable about these types of problems. All right, thank you so much for watching. Keep up the hard work.